Good evening, and welcome to our flipped classroom. You should have out a pencil, your 5.5 notes, and a highlighter to begin. If you do not, I would pause and go get it, because you will need them. We're doing Proving Triangle Congruence by SSS. SSS stands for side, side, side. And then the second half, if you see the second bullet point, would be using the hypotenuse leg congruence theorem. All right, so we're learning two new theorems, and we're going to begin. So the first you'll want to write in at the very top of your page, you're going to see theorem 5.8. You're going to write in that it's called side, side, side congruence theorem. And it is that if you have three sides of one triangle congruent to three sides of a second triangle, then that is enough information to prove that these two triangles are congruent. So, let's talk about that. So the first thing that you'll want to write in, you'll see a blank for it, is that side MN is congruent to side QR. Alright, so there's our first S. Our second would be that NP is congruent to RS. Now make sure that you're also filling in over here on the triangles, that you're also filling in those tick marks. They're very important. Okay, the one tick mark is congruent to the one tick mark. The side with two tick marks is congruent to the side with two tick marks. Alright, so we have side, side. We need a third pair of sides, which would be PM and SQ. If they are also congruent, then this is enough information to prove that two triangles are congruent. So there's your side, side, side. If at any point in time this is too quick for you, always hit pause and give yourself some time. Alright, but we're going to move on to our first example. It says write a proof. We're trying to use side, side, side congruence theorem. Alright, so let's see. We need a side, and a side. If you look, we're trying to prove that two triangles are congruent. We're trying to prove that KLM and NLM are congruent to each other. So let's look at what they gave us. They said that KL and NL are congruent. So guess what? That's a pair of sides. We're going to write it. KL is congruent to NL. I really didn't even have to look at the picture for that because it said it. For my second pair of sides, again, it says it right here. It says KM is congruent to, what is it, NM. Alright, so we can write that in. KM is congruent to NM. So we have side to side and no more given information. So we're going to need to find where our third side is congruent. Well, we've named two sides congruent to two sides. They also share a side. Because of the reflexive property, it's not marked, but we know that if KLM has this portion of the side and NLM has this portion of the side, it's the same side, so it is congruent to itself. So you can say LM is congruent to LM. This would be enough information to prove that two triangles are congruent because we have side, side, side. So this would be your final answer. So we're going to go through this section, decide whether the congruent statement is true, and explain your reasoning. So we have triangle DFG is congruent to HJK. Alright, so let's look at what we have. We have a side marked congruent to a side, so we got a side. We have another side marked congruent to another side. And then we have a third side marked congruent to a third side. So this would be called side, 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 and that is enough information to prove that two triangles are congruent. So we would say yes by side, side, side theorem. And that's it. On the second, we're trying to prove or decide if ACB is congruent to CAD. D. All right, so they obviously share AC, so that's congruent to itself. BC's length is 7, as well as AD's, so they're also congruent. However, my third sides, their lengths are 3 and 4. All right, so 3 and 4 are not the same number, so they're not the same length. So we only have side, so we actually don't have enough information. So no, because only 2 sides were congruent. Only 2 sides were congruent. Or you could say side AB is not congruent to side CD, like it needs to be. So either one of those answers would be just fine. In our last example, we have a side marked congruent to a second side marked congruent to a second side, and a third side marked congruent to a third side. So yes, this is enough information because of side theorem. This next section you will need your highlighter for, so make sure that you have it out so that you can highlight what I will ask you to highlight. This is the introduction to what we call hypotenuse leg theorem. So the first thing that we actually want to talk about is, where is a hypothesis? What am I talking about? Where is a hypotenuse? A hypotenuse is a side in a right triangle. So if you look at this bottom section, it talks about a right triangle. So I'm going to draw my right angle. In a right triangle, the sides adjacent to the right angle are called legs. So remember, adjacent means next to. So these 2 sides are next to the right angle. So that makes them a leg, a leg. The side opposite of the right triangle, the one that the right triangle is always pointing to, we call this the hypotenuse. Hypotenuse. It only exists in a right triangle. Okay, so let's talk about why this matters. You know, side angle side and side are valid methods for proving that 2 triangles are congruent. What about SSA? All right, I want you to put a box around what about SSA. And then take out your highlighter. In general, SSA is not a valid method for proving that 2 triangles are congruent. Y'all, think about this. Okay, it's called SSA. What does that spell backwards? That is not TCA approved. That is not a theorem. So many students still write it on their test as a theorem. It's not a theorem. Stop trying to make it a theorem. It will never be a theorem. So, forget about it. In the triangles below, 2 pairs of sides and a pair of angles not included between them are congruent, but the triangles themselves are not congruent. So AB is congruent to DE. Angle A is congruent to, so that's a side, marked to a side. Angle A is marked congruent to angle D, so it's an angle and an angle. And then, I'm not going to write this one, but BC and EF are sides that are marked congruent. But those sides are marked congruent. Sorry, Miss Rockefeller interrupts me often. But those 2 are also marked congruent, okay? But I'm just going to write side. Side. All right, so this is not a valid reason for them to be congruent, because they're not congruent. Congruent means all of the sides are congruent, all the angles are congruent. But if you look at the picture, angle E is not going to be congruent to angle B. And the same for C and F. So that means the triangles are not congruent. All right? While side down here, while side is not valid in general, there is a specific case just for right triangles. Okay? So let's go ahead and flip to the next page of our notes. At the very top, you're going to see a section that looks like this, a triangle, a right triangle that looks like what we just drew. If a hypotenuse, take out that highlighter, if a hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. So if we look, my two hypotenuses in my picture would be AB, marked congruent to, what is that, DE. All right, and then the two legs that are marked congruent, so those were my hypotenuses. They're across from my right angle. So the two legs that are marked congruent would be AC and DF. So AC and DF. This would be enough information to prove that two right triangles are congruent. So make sure you have these highlighted up here. And then you're going to see a box that says only works for blank. Only works for right triangles. No other triangle has a hypotenuse, so why would hypotenuse leg be a reason to prove that two triangles are congruent if there's no hypotenuse? So you need a hypotenuse, you need a right triangle, so this only works for right triangles. Again, that goes in that top left box on this section of notes. We're going to decide if these two triangles are congruent by the hypotenuse-leg theorem. So let's look for a pair of hypotenuses, I'm not sure, hypotenuses that are congruent. So let's look across from, in my first triangle, across from the right angle is AB, and it is marked congruent. Let's look at the second triangle. Across from my right angle is XZ. It is also marked congruent, and they're marked congruent to each other. So I have a hypotenuse, AB, marked congruent to hypotenuse XZ. Now all I need is a leg marked congruent. All right, so let's look for a leg. I do see one. AC is marked congruent to ZY. So AC is congruent to ZY. So this would be a yes. We can determine if the two triangles are congruent by the hypotenuse-leg theorem, because a pair of hypotenuses were marked congruent and a leg were marked congruent. So this is enough information. And then our last section, you're going to see them on your bottom of this section, or this page. We're determining if two triangles are congruent. So we need to think back to all of the congruence theorems. Okay, we learned about side angle side. Okay, side angle side was when you had a side marked congruent to side, an angle marked congruent to an angle, and a side to a side. However, you need to remember that these angles had to be included. And included means between. Okay, if not, then that would be that SSA, and that doesn't exist. So we did side angle side. We just learned today about side, side, side. And then we learned about hypotenuse-leg theorem. There are two left that we have not learned, but they're not going to be quizzed over right now, obviously. So let's go through here, decide if two triangles are congruent, and explain why. So I always tell you to kind of outline one of your triangles to compare to the other. So I'm going to outline this left triangle. I have a side marked congruent to a side. I have a second side marked congruent to a side. And it appears I don't have a third side. However, both triangles share this side. So this would be my third congruent side. So if these two triangles are congruent, explain why. Yes, because of side, side, side. We just learned this one today. We're going to go ahead and move on to the second. I always outline one of my triangles. I have a side marked congruent to a side. I have another side marked congruent to another side. and then again a side that they share. So this would be side, side, side. So yes, they are congruent because of side, side, side. Alright, the next I have a side. I'm going to compare my left triangle to the one on the right. I have a side marked congruent to a side, a second side marked congruent to a second side, and a third side marked congruent to a third side. So this would also be a yes, side, side, side. I do promise that not all of them are side, side, side. It just so happens that these are, because we're going to look at our next example. I'm going to outline the triangle above. I have a side marked congruent to a side. Then I have an angle marked congruent to an angle. Alright, and then it appears that I have nothing else except for they share a side. So that means that that side is congruent to itself. So yes, there's enough information because I have side, angle, side. See, I told you not all of them are side, side, side. This next one, we're going to compare my top triangle to the bottom one. I have a side marked congruent to a side. I have an angle marked congruent to an angle. And a side that they both share. But here's what you need to see. On the top, it is side, angle, side. My angle is between my two sides. On the bottom triangle, I have two sides marked congruent, and my angle is not included. Included means it would be between my two congruent sides. So this would actually be no, not congruent, because I needed an angle here for it to be side, angle, side, and it's not. It's marked congruent over here. Alright, my last one. I have a side marked congruent to a side. I have a right angle and another right angle. Well, right angles both represent 90, so they are congruent to each other. And then I have a second side marked congruent to a second side. So this would be yes, because of side, angle, side. My angle was directly between my two sides in both pictures. Alright, so that was enough information to prove that my two triangles are congruent. I believe this is where we reach an end. I hope you have a good night and come back in tomorrow. Oop, not that. Come back in tomorrow with these notes filled out, and I will see you. Bye.